I'll go ahead and record this as well. If anybody misses class, they can get caught up. All right, cool. Okay, so today, actually, let me unpause this. All right, there we go. All right, so today what we're going to be talking about is the section's called trigonometric functions of angles. And the big idea here we are looking at is the unit circle. So this is the unit circle here. And so the unit circle is, did I put a definition here? No, I didn't. So let me just tell you what the unit circle is. So the unit circle is a circle that allows us to evaluate the different trigonometric functions at different angles, okay? So some things you'll notice about the unit circle is that, and I think I mentioned yesterday, in normal years, we kind of memorize this unit circle, but this year, since everything's open note, you know, obviously that doesn't really make sense. So we're going to go ahead and just know how to use it, okay? It's going to be the key here. So a couple things I wanted you to notice. So we kind of have three aspects of the unit circle, I would say. Along the circle on the outside are points, okay? And these are the most popular points on the unit circle. There are other points on the unit circle. For example, like we could draw a point right there, and with like technology or something, we could figure out what is the point right there. What are the coordinates? I'll tell you, we don't really care about that. We really only care about these popular points, okay? So here, this point is 1, 0. So the radius of this circle is 1. So that makes sense that that's 1, 0. Up here is 0, 1. Over here is -1, 0. And then down on the bottom is 0, -1. So those points are all kind of easy, I would say, to remember. People do get tripped up between the X and the Y. So remember, you know, the X is first. So this would be 1, 0. And then the Y is second. So this one's 0, 1. In between there are some more complicated looking points. So for this first one, we have rad 3/2, 1/2. So rad 3/2 is about like, it's about 0.77 last time I checked. So obviously 1/2 is 0.5. So it's a little more to the right than it is up, which makes sense with how it looks. And then I kind of always match that up with this point up here, the 1/2, rad 3/2. So you can see that one's kind of the same, except the X and the Y are reversed because the Y is bigger and the X should be smaller because it's a higher up point. In the middle here, you have rad 2/2, rad 2/2. And so that's kind of in between on both of those, in between 0.5 and 0.77. So that's the point right there. Then all these points kind of repeat as you go to the different quadrants. So you can see on this quadrant, X is negative, but Y is still positive, which makes sense for that quadrant, the second quadrant, correct? And then down here, they're both negative. X and Y are both negative. Over on the right side, X is positive, Y is negative, because they're on the right side, okay? And it does go around like that. And so now I'll kind of take a look at the inside here. And on the inside, we have angles. And there's kind of two ways that they write the angles. So they have a degree there, and then they have a radian there, okay? We know that radians and degrees are just kind of different ways of saying the same thing. And so every time we see a degree here, this is just the equivalent radian. So this would be 0 degrees, 0 radians. 30 degrees, pi/6 radians. Skip a few here, there we go. So 90 degrees is pi/2 radians. We've talked about that, I feel like. 180 degrees is pi radians. We've definitely talked about that. And then on down to the bottom part there. So those are all the equivalent radian amount, okay? All right, something else I like to point out is I like to draw 3 rectangles here. And if you have color coding here, that really helps. If not, though, it's okay. You could still kind of draw them lightly. So I always match up these 4 points I feel like are connected. I don't want to cover up that 135. Hold up, I'm going to do the sheet there. And then if I go down here, and if I go over here, I don't want to cover up that 315. And I go back up here. So those 4 points to me are connected. If you look at all of their coordinates, they're all actually the same coordinates, except different positivity or negativity based on the quadrant. So we got 5 pi/6 is negative rad 3/2, 1/2, and then down on the third quadrant, 7 pi/6 is negative rad 3/2, -1/2. And then 11 pi over 6 is rad 3 over 2 gamma negative 1/2, okay? The other thing I notice about those is that the denominator, okay, the denominator in all of the radian measurements are the same. Notice that. So we got pi over 6, 1 pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Those are all of the pi over 6s, all right? Awesome. So that is a cool thing that I always look at there. We can do another rectangle. That's kind of the tall rectangle. So that one goes like from here down there, and then over here, and then down here, and then over there. And so kind of same relationship with those ones we see. We have all of the same points, so 1/2 comma rad 3 over 2 on all of them, but with different positivity or negativity based on the quadrant. And we see that all of the denominators on all the radians are 3. We got 1 pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. You can see the one that's kind of missing is 3 pi over 3, but actually 3 pi over 3 is just pi, right? So that actually is there. So that's cool as well. All right, the last rectangle that I like to connect is actually a square. But if you remember from geometry, a square actually is a rectangle. All, what do they say? All squares are rectangles, but not all rectangles are squares. That's a fact. All right, so on these ones, we have all of our rad 2 over 2, comma rad 2 over 2s, but with different positivity and negativity based on the quadrant. So that's fun stuff. And then we also notice that all of their denominators are 4, okay? Awesome. So I love this thing. I think it's beautiful. If you take a look, can you see it? Oh no, I have my Zoom background on for UCLA, but hold up. If I turn that off, which I'd like to do actually, even though I'm very happy about UCLA. Okay, up here I have a clock, and on that clock is actually the unit circle. So that's pretty cool. Boom, there you go. It actually doesn't tell time, but that's okay. Like the hands are broken, it's old. Cool, so yeah, to me, this is like one of the most beautiful things in the world. Of course, my wife is number 1, and then the unit circle, and then like a beautiful sunset. So that's my power rankings of beautiful things. Got to go with the wife first though, for sure. Okay, so how do we use the unit circle? Okay, well, it's all based on this picture over here. Okay, so whenever we are picking an angle, it creates a triangle in here. All right, and so if we kind of identify this triangle, we go across here, then that means that y is our opposite side. This would be the hypotenuse, and then x would be our adjacent side, okay? So that's very key. I would definitely fill that out. That's going to kind of inform what we're going to do next. But before we do that, I wanted to quickly point out, why is the hypotenuse 1? Well, remember I told you that no matter which direction you go, if you go along the straight lines here, like from the origin out to 1, 0, the radius of the circle is 1, correct? And so the radius of a circle is consistent no matter which direction you're going. And so even if I'm kind of somewhere in the middle here, my x and my y values will change, but my radius, which is my hypotenuse, is going to be always 1, okay? So that's very important as we go along here. So now, oh, we could fill this out. Shoot, this is supposed to be the definition of the circle. It's a circle with radius of 1 unit, and its center at the origin. It helps us find the lengths of trig ratios without a calculator. Okay, so how are we going to do this without a calculator? Well, what we're going to do is sine of theta equals, and if I go back, I'm going to go back up to, actually, I'll do it on this picture as well. So we know the radius is always 1, right? And then we said this one was opposite, this one was adjacent, and then this one was the hypotenuse. So according to that picture, the sine of theta would be y over 1. Right? So we got opposite is y, hypotenuse is always 1, so that's going to be y over 1, okay? Well, y over 1, I'm just going to simplify as just y. Anything divided by 1 is just itself, right? Okay. All right, so then cosine of theta is going to be x over 1. So adjacent over hypotenuse, which will just be x, correct? And then tangent of theta would be y over x. And I actually do not even think that we need an equal sign there because that's not going to simplify into anything, right? All right. Okay, next up, we'll do the reciprocal functions here. So we get cosecant first. So cosecant is going to be 1 over y. But oftentimes, what we're just going to be doing is flipping y. If it's already a fraction. So if it's already a fraction, you can just flip it upside down. And we're going to see very often it is a fraction. So instead of doing 1 over the fraction, which would mean we multiply by the reciprocal and flip it anyway, I'm just going to say you flip y, okay? So then secant is going to be 1 over x, which again, we can just, if x is a fraction, we can just flip x. If x is not a fraction, which we are going to see a few of those, then I would do 1 over x. But if x is a fraction, just flip it. Okay, and then lastly, for cotan, we're going to do x over y. That one, I would just do x over y, okay? I wouldn't flip tangent because then you have to like find tangent and flip it. If you're just doing cotangent, I would just find x over y, okay? Awesome. So that is kind of all of our breakdowns there. So that's how we're going to read this. So very important right here. What am I looking at? If I'm looking for sine, I'm going to look at the y value on the point, okay? If I'm looking at cosine, I'm going to look at the x value on the point. If I'm looking at tangent, it's going to be y over x. I actually don't want to do this whole page. I decided, let's skip it. So let's actually go down and do this set right here, okay? So this is at kind of the bottom of page 3. I'm actually gonna, let's go ahead and split screen this with, I got a unit circle handy here. So that's gonna be good for us. I'm just gonna remind myself on the unit circle that we remember sine is the y value, cosine is the x value, and tan is y over x, right? All right, so now let's do some of these problems. So the first one says what sine of 60 degrees, okay? So sine of 60 degrees means I go to my unit circle and I find 60 degrees. Where's 60 degrees? Well, 60 degrees is right here, correct? Okay, now I go to the point. And since we're talking about sine, I'm going to look at the y value. I see the y value is radical 3 over 2. So my answer here is the y value, which would be rad 3 over 2. That's it. So that's how you use the unit circle. Next question is asking me about cosine of 210 degrees. So now I go find 210 degrees. I find it right here. It's in the third quadrant, bottom left. Cosine we know is the x value. And so I'm going to go back to here and I'm going to say my x value right there at 210 degrees is negative radical 3 over 2. That is it. We are done. Now, could you just type these into the calculator and get those answers? Well, kind of. If you typed those into the calculator, it would give you decimal answers. Now, the decimals would be equivalent to these, but WebAssign is going to, on this section, want the radical form. So you do need to know how to read the unit circle, okay? Now, do you have to have the unit circle memorized? Again, no. Okay, so let's do another one then, tan of 300 degrees. So now I'm gonna go to 300 degrees down here, bottom right, okay? And we know tan is y over x. So y is negative rad 3 over 2. X is a positive 1/2. So I have negative rad 3 over 2 over 1/2. Well, for dividing fractions, we've always multiplied by the reciprocal. So I don't see why we would want to change that now. So we can cross cancel the 2's. I get negative radical 3 over 1, which I would just write as negative radical 3. All right, next up, cosecant of 135. So let's go over to 135. I see it right here. So we know that cosecant is the reciprocal of sine. So I am just gonna, I see that sine here is y, sine is rad 2 over 2. And so what I told you guys is that if sine is already a fraction, I'm just going to flip sine. Or actually, did I say flip y, right? I think I did. Either way, sine is y, so I could say that either way. And so if I flip y, it's going to be 2 over rad 2. All right. Should we? No, that's fine. Okay, let's just leave it like that. We remember we are usually allowed to leave radicals in the denominator, so that's why I'm just leaving it like that, okay? All right, next up, secant of 570. Whoa, 570. 570 is not on the unit circle, correct? Okay, and why is it not? Why is 570 not on the unit circle? Is it like in between two pieces? No, not really. 570 is not on the unit circle because it's too big, right? Okay, the biggest angle we have here in degrees is 570 degrees. So what are we going to do about this 570? Well, this is going back to 6.1. Remember when we were finding the coterminal angles? This is why we found coterminal angles. Because if you have an angle that's too big or too small to fit on the unit circle, you find the coterminal angle and just use that. So I'm going to actually subtract 360 degrees here. Remember, that's how we did that with degrees. We added or subtracted 360 degrees. So I'm going to see that it's actually asking me for secant of 210 degrees. Is 210 on our unit circle? Yes, it is. In fact, we've already used it, correct? It's down in the bottom left. 210 degrees right there. So I said for secant, we're going to flip x, correct? If it's a fraction, and it is a fraction. So my x value there is negative rad 3 over 2. So I'm going to say negative 2 over radical 3. All right, next up here, number 6, I got cotangent of negative 225. Now, there's no negative angles on the unit circle, all right? And so if you have a negative angle, this is another example when you would use a coterminal angle. So I'm going to now add 360 degrees because now my angle is too small. And that's going to give me cotangent of, this is a tricky one to do in your head because it's 360 minus 225. Okay. 5, 10. So 5, and then that would be 3, and that would be 135, right? Yes, that sounds good. Is 135 on the unit circle? You're gosh darn right it is. It is back over here in the top left. We've actually already used it as well here. All right, so we know that cotan is actually x over y. And so that is going to be negative rad 2 over 2 over rad 2 over 2. Now we could multiply by the reciprocal on this one, but isn't this the same thing divided by itself, but one of them's negative, right? So if I said like, what's negative 5 divided by 5? Wouldn't you say negative 1? If I said negative 10 divided by 10, would you say negative 1? If I said negative x divided by x, would you say negative 1? Yes. If I said negative rad 2 over 2 divided by rad 2 over 2, would you say negative 1? Yes, you would. All right, let's do secant of 660 now. So again, too big. So I'm going to subtract my 360 here. So I get secant of 300. So 300's right there. We've already used it. Same as 5 pi over 3. So secant is the reciprocal of cosine. So I'm going to flip. I see that cosine x is a fraction here. So I'm just going to flip x. So if you flip 1 over 2, you get 2 over 1, which I'm actually just going to call 2. Is that all right? It's really 2 over 1. Okay. All right. Next up, number 8 says cosine of 5 pi over 3. So the only thing they've changed now is now they're talking radians instead of degrees, right? But honestly, it doesn't really change how we're going to do these. Cosine of 5 pi over 3. What we're going to do is we're going to find 5 pi over 3, okay? I think it'll be on there, and you can see that it is. So it's just when we're looking on the inside, we're looking for radians instead of degrees. But the radians are right next to the degrees anyway, correct? So we're actually looking at that same 300-degree spot that we were looking at on the last problem. Now we know cosine is x, right? So at that spot, what is x? Well, x is 1/2. We know that really well from our last problem, correct? Because we just flipped x upside down and got 2. So now it's asking for the cosine of that same spot, so that would be 1/2. Easy. Okay, next up we have tangent of pi. So we're going to look for pi radians. That is over here. We have not used that one yet on the far left. So that one, the coordinates are -1, 0. We know tangent is y over x, correct? So y over x would be 0 over -1. What is 0 divided by -1? It is 0. Wait a minute, Mr. Barry, isn't that undefined? No, this one is 0. We are actually going to see some undefined, but what makes a fraction undefined is not 0 in the numerator. What makes it undefined is 0 in the denominator, okay? All right, let's do a few more in the radians here. All right, so next up, we're going to do cosecant of 7 pi over 4. So we got to find 7 pi over 4 on the radians on the unit circle. So I found it down on there on the bottom right. We know that cosecant is the reciprocal of sine. So I'm going to flip y. So that would be 2 over, oh no, it wouldn't, it would be negative. -2 over rad 2. Okay, secant of 3 pi over 2. So 3 pi over 2 is down here on the very bottom of the unit circle. So we have 0, -1. Now, I told you that secant, you flip x, correct? But that's only if x is a fraction. In this case, x is not a fraction. X is just a integer, 0. And so I'm actually going to use the other definition that I wrote there, which is 1 over x. So I would only do that flip x if it's a fraction. So when you're at like the very top, the very bottom, the very left, or very right, the numbers aren't fractions, they're integers. And so then I would use the 1 over whatever, use the other definition. So this is going to be 1 over 0. And this is the one where we are undefined, okay? So 0 on bottom is undefined. 0 on top is 0. Okay, sine of 16 pi over 3. So we look at the unit circle, try to find 16 pi over 3. You should see that 16 pi over 3, not on the unit circle. Why is it not on the unit circle? Because it's too big, okay? If we look at all our over 3s, the biggest over 3 we have is 5 pi over 3, right? And this is way bigger than that. So once again, we have to find a coterminal angle here, okay? So for coterminal angle for radians, remember what we do? We are going to add or subtract, in this case, subtract 2 pi, right? But I wouldn't actually subtract 2 pi. I'm going to subtract 2 pi, but with a common denominator. So if I'm over 3, what's 2 pi with a common denominator over 3? It would be 6 pi over 3, correct? The trick with the coterminal angles for radians, the numerator should always be double the denominator because that would reduce to 2 pi. And that's our goal here. 2 pi is the whole circle. Oops, excuse me. Silence the phone, Barry. All right. So what do we get then? 10 pi over 3. Now 10 pi over 3 is actually still not on the unit circle. It's actually still too big. So what do we do now? Well, you can actually subtract 6 pi over 3 again. So you kind of have to do it as many times until you get a number that is on the unit circle. Once we do that, I think now we actually do have a number that's on the unit circle, and that would be 4 pi over 3, correct? So 4 pi over 3 is not our answer. We have to go to 4 pi over 3 on the unit circle, which is in the bottom left quadrant, the third quadrant. We know sine is the y value, so the y value at 4 pi over 3 would be negative radical 3 over 2, so that is our answer. All right, next up, number 13, tan of negative pi over 4. Now remember I said with degrees, we don't have negative angles on the unit circle. And so radians is kind of the same deal. So we have to do coterminal angles again. So I'm going to do negative pi over 4. I'm going to add 2 pi, but I want 2 pi with a common denominator, right? So I would make my numerator 8 pi. So that would reduce with the 4 to give me 2 pi. So I have negative pi over 4 plus 8 pi over 4. And so what I'm really looking for here is tan of 7 pi over 4. So now I'm going to go back to the unit circle. 7 pi over 4. We know that tangent is y over x. So that would be negative rad 2 over 2 divided by positive rad 2 over 2. We could multiply by the reciprocal here, but we don't really have to, because anytime you have the same thing divided by itself, it's 1. Anytime you have the same thing divided by itself, except one of them is negative, that's going to be negative 1. All right, 2 more to finish our day, and then we'll wrap these notes up tomorrow. All right, so we have another negative angle here. So we're going to add our 2 pi, but we need common denominator, right? So this is going to be over 6. So what is 2 pi with a common denominator of 6? Well, I would think that would be 12 pi over 6. And so what I'm really looking for here is cotangent of 1 pi over 6, which we usually just call pi over 6. All right, so I'm going to go to pi over 6. That is in the first quadrant. We have not used pi over 6 yet. It's actually the first angle. Well, I guess 0 is the first angle. So we'll call it the second angle. All right, we know that cotangent is x over y. So that is going to be a positive rad 3 over 2 over a positive 1/2. This one's not 1. This one's not negative 1. We have to multiply by the reciprocal here. So times 2 over 1. Cross cancel, and this one comes out to radical 3. All right, final one. 5 pi, obviously too big to be on the unit circle. So I'm going to subtract 2 pi. Oh, this one's not a fraction, so I can just subtract 2 pi, right? So then that would be cosecant of 3 pi. Well, 3 pi is actually still too big, so I'm going to have to subtract 2 pi again. So we're actually going to do cosecant of 1 pi. That's the kind of math you need to know if you're working at Marie calendars, you know? If you have 5 pi's, but then you sell 2 pi's, then you have 3 pi's left. Get it? Because Marie calendars, they sell pi. Okay. All right, cosecant, we know is, what is that? The reciprocal of sine, right? So at pi, which pi is over here, I see the sine value is 0. Now, remember I said for when it's not a fraction, we want to use the definition 1 over y. So that's going to be negative 1, or no, it's going to be 1 over 0, which will be undefined. All right.